On this video, we're going to go over 3 questions. Number 5 from page 100 on the homework, number 7 from page 100 on the homework, and number 31, the last one on the homework from page 100. Let's take a look at this guy right here. Number 5. Now, keep in mind, the first step to solving any equation is to simplify one side at a time. So what I'm going to do is block out one side and just focus in on one side at a time. Let me create a little block here. So I want to cover up the 2n for a little while, and I am going to simplify the left side of the equal sign. So focusing in just on the left side, I want to distribute 2 times n, and I'll get positive 2n. Now I distribute 2 times 1, and I'll get positive 2. And then I bring down the 5. So I have distributed. Now I have 3 terms that I could still combine, or combine like terms. I have a 5 and a 2, so I could combine both of those. I'm just going to underline the 5, underline the 2. Now this is on the same side, so I'm just going to combine it in my head. 5 plus 2 is 7. That's right. So let me rewrite this whole thing. I have a nice beautiful 2n. I have a plus 7 because 5 plus 2 is 7. And that's all I could do on the left side. That's as simple as it gets. So what I want to do now is take the equal sign and bring it down, put the equal sign right here. And now I'm going to worry about simplifying the left side. So if I move this over, and let me forget about the left side for a while. I'm sorry, we're going to simplify the right side. And on the right side, there's nothing to do. It's a nice, beautiful, simple 2n. So all you do is bring that down. Let me get this, let me get that out of the way. So I'm going to bring down the 2n. And ladies and gentlemen, we have this simple equation right here. Now, the goal to solving any equation is to get n by itself. Is n on the left side of the equal sign or on the right side of the equal sign? It's on both. It's on both sides. So you want to get it by itself on one side. You don't want it on both sides. So let's get rid of one of them. I'm going to get rid of this guy. Or, no, I'm going to get rid of this guy. Yeah? I want to subtract 2n. I want to subtract 2n. That cancels it out. Now, what I do to one side, I have to do to the other. Now, over here, what? It also cancels. It disappears. 2 take away 2 is 0. So I really have the 7, the equal sign, and everything canceled. So that's a 0. So, ladies and gentlemen, we have something impossible. No solution, right? This right here, 7 equals 0? No. You're going to say no. And no solution. No solution. Or you could do the little 0 with the slash. That's the symbol for no solution. And that's how we do question number 5. Piece of cake, right? Expect to see, why did that 2 not go with it? That's weird. Well, expect to see that type of question on the test. For sure, we're going to have some that have no solution. Let me just move that junk to the side. Let's move on to the next one, number 7. And here we go. Let's simplify number 7. Again, we're going to simplify one side at a time. So let me cover up this side. Is there anything to do on the left side? No. There's no distributive property. There's no combining like terms. So technically, this side is simplified. So now let me just move it over and cover up that side. Let me just focus in and simplify the right side. 2 times 5 is 10. 2 times 7 is 14 with the v. And let's bring down the minus 4 that's out there at the very end. Now I have those 3 terms, 10, 14, v, and minus 4. I could combine, out of those 3, I could combine the first one and the last one. So I want to combine this 10 with the minus 4. Now you're not doing the opposite, right? You're just combining like terms on the same side of an equation. You do that in your head. What does 10 take away 4? 6. So we really have 14v plus 6, because 10 take away 4 is 6. So we have that side that's simplified. The left side was already simplified, so let me just bring everything down and rewrite it. I want to bring down the equal sign, the 6, the plus, the 14v, and here's my new equation. Now at this point you could stop already. Why? Because you have the left side that's identical to the right side. In other words, it doesn't matter what v is. If you plug in v in both of these, your answer is always going to be true. right? Now, let's say you didn't see that right off the bat, and you kept solving. You're like, oh, I want to get v by itself on one side. Let me subtract 14v. It cancels. Subtract 14v, and you're like, what? It also cancels. So what do you have left? You have 6 equals 6. And that's always true, always. So what does it mean that the v's canceled out? That means that your v value is equal to all real numbers. V could be any real number. V could be, you could plug in a pi right here and a pi right there, and it'll give you a true statement. You could plug in a square root of 7 right here and square root of 7 right there, it'll be a true statement. You could plug in negative 200 right there and negative 200 right there, it'll be a true statement. Why? Because it's always going to be a true statement. Because the v is canceled out. It doesn't matter what v is. V could be any number you want. So your answer is v equals all real numbers, or you could actually write it out in words. All real numbers. It's up to you, whatever you like. Expect to see a couple of those on the quiz or test tomorrow, depending on how well you guys do. Why is it not? This is so weird. Okay, again, I'm just going to move all this junk to the side. It's like I'm sweeping the floor. Number 31, the most fun one of them all, because it has fractions. Okay, so I'm going to do this a couple of different ways. The first way I want to do it is by getting rid of fractions. Okay, so let's say I wanted to get rid of any fraction. All I have to do is multiply everything by the denominator of the fraction that I want to get rid of. So if I wanted to get rid of the 2/5, I'd have to get rid of the divided by 5 by multiplying by 5 and multiplying by 5. Now, I do not multiply the inside values by 5 because whatever I do to this outside guy, it's like if I'm doing it to the inside guys because of distributive property. You guys understand? So if I decide to multiply by 5 and multiply by 5, it'll get rid of this one only. And then I could get rid of the 1/3 by multiplying both sides by 3. Or I could do both at the same time. I could get rid of both at the same time by multiplying everything by the LCD. I don't know, what do you guys think? Multiply everything by the LCD. What is the LCD? 15. So if I wanted to, I could put a times 15 right here and a times 15 over here. And you could cancel the 15 on top with the 5 on the bottom, and you'll have a 3 left over up on top. So 3 times 2 is 6m equals, and over here the 15 on top and the 3 on the bottom cancel, and you get a 5 left over. So you're really going to distribute that 5 that's left over. So when you distribute the 5, you're going to end up with a 10m minus 60. And now it's just a regular equation with variables on both sides. I need to get the m's by itself on one side. What do I do? Subtract 10m. Subtract 10m. So you get negative 4m equals negative 60. My final step would be to divide by negative 4 and divide by negative 4. So you get a final answer of m equals positive, what is that? 15. I believe that's the quickest way to do it, but there's other ways of doing it. Maybe we should try a couple of other ways. So I want to, what just happened? I want to zoom this out. Hey, that all moved in one piece. Cool. All right, that's gone. Let me do that same problem a slightly different way. Let's say you didn't want to get rid of the LCD. Before I do that, let me do this one more time. Let me get this out of the way, just in case you want to try it even a third way. So let's say you wanted to get rid of the 5 only. Times 5 cancels times 5. Now, this 5 right here does not cancel with the 3, so you actually have to multiply 5 times 1. Let me rewrite the whole thing. 2m equals 5 times 1 is 5 over 3, parenthesis, 2m minus 12. So you can get rid of one of them at a time if you'd like. It's also the same thing, right? Or you get to the same answer anyway. Times 3 cancels times 3. You get 6m equals 5 times 2m minus 12. So you'll get to the same answer anyway. So that's just another option. If you don't want to use the LCD, you could get rid of one fraction at a time. Are we good? Okay. Let's try even another way of doing this. Another way of doing it, I think LCD is the best. Multiply this by 15 and this by 15, I think that's the best. But another way of doing it is to deal with the fraction for a while and distribute. And you would actually have, put this over 1, and you would actually have 2 over 3 with an m on it. And then when you distribute over here to the 12, you'd have a minus 12 over 3 with the equal sign, and then bring down the 2m over 5. So this is a third way of doing it. The 12 over 3 over here actually becomes a 4. So you're going to have a minus 4 with the 2/3 m with the equal sign with the 2/5 m. But either way, you'd still have to get rid of fractions by multiplying everything by 5 to get rid of this fraction. And then you'd have to multiply everything by 3 to get rid of this fraction. Or again, you'd have to multiply everything by the LCD 15 to get rid of both fractions at the same time. So I think the easiest way to do it was the first way, where we simply multiply everything by the LCD right from the start. Did that help you guys, or did that confuse you guys? Doing it all those ways. Helped, I guess? Okay. So this will be on Edmodo. Quiz or test is tomorrow.